Okay, so let's talk about simplified radical expressions. So for real numbers a and m and n that's greater than or equal to 2, the nth root of a is considered simplified if a, the radicand, has no factors of m to the power of n. So basically what this is saying is a radical is considered simplified if the radicand has no powers larger than the index. So for instance, for question 3 here, when it says simplify the radical expression, I look at the radicand and I notice that the exponent of the radicand is 13, which means since 13 is bigger than 3, this is not simplified. I need to simplify it into a smaller power of x underneath the radical and figure out how many powers of x I can take out, how many factors of x I can take out. So what we do in order to achieve that end is we try to figure out how many times 3 can go evenly into 13, and that's a long division problem. So 3 goes into 13, let me see, that will be 4 times. 4 times 3 is 12. 12 is an important number in doing this, and so is 4. And the other important number is the remainder here that I get, 1. So let's keep these numbers in mind as we go through and do this. These numbers here. All right, so first thing I want to do is I want to split this up. I'm going to take the cube root of x to the 13th, and I'm going to break it up into the cube root of x to the 12th times the cube root of x, or just times x to the first. Where did the 12 and the 1 come from? Well, if you remember, 1 was the remainder, 12 was what I got when I multiplied 4 by 3, the 12 here, and the significance of that is that 1 plus 12 equals 13. That'll always be the case. These two have to add up to this one because this was a subtraction problem. So we know that this product should equal x to the 13th. Now that we have it broken up correctly, we're going to simplify this now by splitting it up using the product rule. It's going to be the cube root of x to the 12th times the cube root of x. And then that first one needs to be worked on. This last one is a simplified radical. To work on that first one, I need to figure out what power of x I need to cube to get x to the 12th. The answer is up here. You could just divide 12 by 3, you'll get the 4. That's the point of that long division. So I can rewrite this as the cube root of something to the 3rd power. That thing I'm raising to the 3rd power is x to the 4th power, because that's equal to x to the 12th, and that's multiplied by the cube root of x. And then, since this is an odd index, I don't have to worry about absolute values. So it's just the cube root of x to the 4th cubed. The cube root and the cube cancel, leaving just x to the 4th. But then I still have to have the cube root of x as the 3rd in my answer. So the answer should be x to the 4th times the cube root of x. That's what we type in here. X to the 4th, x to the power of 4, multiplied by the cube root of x. So let me clear some of this and go back in where I can see this answer palette here. All right, and then I'll hit this nth root button and I'll type cube root, and it's the cube root of x that I'm looking for. So this should be the answer. Boom. All right, moving along, this one is a 4th root. So what I said earlier about the odd root and not having to worry about the absolute value, that's not true here. So once again, I do the whole long division part of it, where I'm seeing how many times 4, the index, goes into 31, the power, evenly. Well, 4 times 7 is 28. And then when I do this subtraction, I get a remainder of 3. So once again, these numbers are going to be involved in doing this. In the first way, I'm breaking this up as the 4th root of x to the 31st power. I'm going to rewrite it as the 4th root of x to the 28th, 28, right? Multiplied by x to the 3rd, x to the 3rd, right? And I know that 28 plus 3 is 31, so this is great. Then I'm going to break it up further into the 4th root of x to the 28th times the 4th root of x to the 3rd. All right? And now all I have to do is simplify this radical. This one is the one that's, I'm going to be able to eliminate the radical completely. So I need to figure out the power of x that I can raise to the 4th power in order to get x to the 28th. And the answer is right here, staring me. We could just do 28 divided by 4, and it'll give us 7 either way. 7 is the number we're looking for. But we still have this 4th root of x to the 3rd power. And then lastly, the 4th root and the 4th power cancel. So the radical and the power of 4 go away. But because this is a even index, when I do that cancellation, I need to have absolute values. I do have to worry about the absolute value. This is the absolute value of x to the 7th multiplied by the 4th root of x to the 3rd. So this is my answer here, because I don't know the sign of x to the 7th. If x is negative, x to the 7th is negative, and the absolute value is its opposite. If x is positive, then x to the 7th is positive, and the absolute value is x to the 7th itself. So because I don't know if that's negative or positive, I can't get rid of the absolute value. So I go through and I'm going to say this is the absolute value of x to the power of 7 multiplied by the 4th root of x cubed. So I hit the root button and I'll do the 4th root of x to the power of 3. And this is simplified because 3, the power, is smaller than 4, the index. So there I've simplified it. And I move on to the last question, question 5 here. All right, so last question in this little subset. Question 5, once again, I'm just going to do a division. I'm dividing 25 by 4. That's going to be 6. And 6 times 4 is 24. I subtract and I get, what's this going to be, 1? So the remainder is 1. The remainder is 1. And once again, these numbers are all going to play a part in getting my answer. So first I break down the 4th root of x to the 25th, and I break it down into the 4th root of x to the 24th times x to the 1st. Where am I getting those from? 1 plus 24 has to equal the x to the 25th that I'm looking for. So then I can break it up into the 4th root of x to the 24th multiplied by the 4th root of just x. And then I just need to figure out what power of x, if I raise it to the 4th power, will I get x to the 24th? And once again, that's usually relatively simple, because the answer is just going to be this number, or what you get when you divide 24 by the index 4, namely 6. So x to the 6th there. And then once again, the 4th root and the 4th power cancel, leaving just the absolute value of x to the 6 times the 4th root of x. Now, the fact that x to the 6 has an even power means that it's always positive, because if you raise a real number to an even power, you always get a positive answer. And the absolute value of a positive number is the number itself. So because I know x to the 6 is positive, I don't need to write it in absolute value. So my answer here is just going to be x to the 6 times the 4th root of x. X to the power of 6 multiplied by the 4th root of x. 4th root of x. And that should be it for 3, 4, and 5.